Okay, this is going to be just a quick walkthrough of these instructions so that you can see concretely what they looked like when actually executed. So the first thing is install GDB multi-arch on your Linux system that you should have set up, an Ubuntu 22.04 system, preferably. So I've already done that. This is just talking about the port forwarding that's going on between the host and the Docker container, and this mentions the port forwarding between the Docker container and the QEMU VM. Then you want to copy your bomb lab, bomb RV64i, into your home directory. I've already done that as well. So the first step I'm going to show you is I'm going to invoke the bomb using the GDB server and listening on port 12345. So this is my QEMU RISC-V system. I'm going to go ahead and launch the bomb, and you'll see that it now says it's listening on port 12345. So first we want to confirm outside of Ghidra that we can actually connect to that, just to make sure all the port forwarding and everything else is going to be set up correctly. So to do that, over here I have user bin GDB multi-arch. Go ahead and run that. And then the magic command here is target extended remote 12345. So we have to run that command. And when we do that, if everything's working out correctly, we will see a bunch of these sort of outputs saying that it's successfully read the symbols from the remote side. Additionally, on the remote side, we will see that it says remote debugging from the host is connected on some port. So if you see this, it's working. If you don't see this, you'll have to close everything down and restart it, and I'll show you how to do that in a second. But now at this point, we've successfully connected from our x86 host OS into the QEMU VM, and we can do things like break on main, and we can continue, and it'll just run the actual executable break on main. We can disassemble main, and so forth. So that says that everything's working, and all the port forwarding and everything is working correctly. So now we can go ahead and quit this on our host OS. Now, the thing is here, I've found that although this does say like, oh, it's listening again and it's, sort of acting like it may be restarted, it's not actually restarting, it's just listening again. So it hasn't actually reset the application or anything like that. If you connected, you'd connect back, you'd be broke at main. So I've found that for reliability purposes, you really want to always start from a fresh instantiation before connecting Ghidra. And the other problem is you can't just like Control-C here and like break out of the GDB server. So what we need to do is we need to actually go in and kill the GDB server process. So to do that, we can do docker ps to see our existing running Docker container, and then we can do docker exec -it, the container ID, and then what we want to exec is /bin/bash, and now we will have an actual shell on the system. Furthermore, then we're going to SSH into the QEMU, so SSH-p for port 2222, and then user at localhost because this has port 2222 forwarded as well into the Docker, into the QEMU VM. So we do that, we enter the password of A for the user, and now we're successfully into the QEMU VM. And now we can do psaux grep GDB server, and we will see the process ID for the current running version of GDB server. We're going to do kill-9 and that process ID, and then we should see that it is successfully killed over here, and we can now start it fresh, and then we can connect with Ghidra. So let's go ahead and restart it fresh, and of course we still want to keep this shell over here so that if we need to restart again, we can just terminate the process. Now let's go into Ghidra. I've already put a new project. I've already put the bomb RV64i. Those were instructions in here. It was telling you, make a new project, do your analysis like you always do, save the analysis, and then we're now at the step of open the binary for debugging. So we go ahead and we drag that over the debugger. This is the UI template that we have in our debuggers 1102 intro Ghidra class. We've got one column over here where we've got our stack and symbols and objects and debugger targets. We've got our decompiler and stuff over here. Anyways, we go to debugger, debug bomb RV64i, and then in GDB locally via GADP. When this comes up, we need to change this from user bin GDB to user bin GDB multi-arch. And then we can hit connect. Now, after we hit connect, we just saw there that Ghidra is going to be problematic. See, it didn't actually successfully launch, so this will be my good example of showing you, how you debug when that happens. Well, I cancel out, I close out, I make sure that I don't have any existing debugger targets still running. I close down that interface. I make sure that it's still listening over here, but just for good measure, I'm going to go ahead and get everything all the way clean. So I'm going to go ahead and relaunch this. Kill-9, and then relaunching it here. So the point is here, Ghidra is a little bit finicky. Usually just closing the UI interface and relaunching it is good enough. But just in case, I decided to reset everything to clean because that's my voodoo dance. When I deal with uncertainty, I want to have a nice dance that I do that just gets me back to a state of certainty. So once again, debuggers, debug bomb RV64i in GDB locally via GADP. And once again, I hit connect. See the little pop-up of the GDB agent? It worked that time. And now once you get this interface, we go ahead and we hit cancel because we don't want to launch. This would be like launching it locally. It's not really going to work because this is a incorrect RISC-V assembly that's going to try to execute on x86. It's not going to work. So we hit cancel, and then down here we're going to enter that command for remote connection that we had from before. So that was target extended remote : 12345. So I'm going to go here. I'm going to copy that and paste it into the interpreter section of the Ghidra interface. So paste that in there, hit enter, and when I hit enter, I see all this lovely stuff that I saw before when I did it outside of Ghidra, and that is your proof that you succeeded. You can see that there was some moving around over here. The dynamic auto PC window has successfully synchronized with this first assembly instruction of the executable. You can actually see over here then it's saying it's at some address, which it's calling _start in some particular library. So basically, this is the code that runs before main, and this is the first assembly instruction. It's as if you had hit start I within GDB. But like the website says,
now witness the power of this fully armed and operational battle station.
Because we've got all the power of Ghidra behind us, and we've got decompiler. So that means we can just immediately see, oh, main has all this, phase 1, phase diffused, phase 2, phase diffused. So we can just do things like right-click over here on phase 1 and set a breakpoint. Or just toggle that breakpoint, do a software breakpoint by default. And from this point, now we could just go ahead and run the executable. And it will eventually hit this, but before it hits that, it's actually going to call readline. So to get the input, we have to go back here, and you can see that the bomb has said, you have 6 phases with which to blow yourself up. Have a nice day. And this is where we said, based on our initial walkthrough of phase 1, that it's requesting some sort of input. So I provide the input over here in the command line window. I go back to Ghidra, and at this point I can see that, okay, it's actually stopped here. I can see because this pause is no longer available. So it stopped here at this particular assembly instruction, which is going to jawl into phase 1. You can see with the little hover over, I can see the assembly for phase 1 without going in if I want. But hey, I've got a decompiler, so why don't I just double click into it and see the actual source code for phase 1. And that's interesting. It's almost as if I created some sort of other executable that doesn't exactly match what I showed you before. So who knows what kind of input this thing is requesting? I mean, you would have to read the fun code in order to find that out. And then we can hit this little back arrow to go back to main. We could go look at phase 2. We could look at phase 3. We could look at all the phases, and it will be a lot easier to read them as decompiled code than looking through all the assembly. Now, of course, the point of this class and the point of this lab is to learn the assembly and get it reinforced. So, I do encourage you to still go through the assembly to a high degree, but the whole point of introducing Ghidra into assembly class in the first place is just to to show that the reality is with today's reverse engineering, you don't need to purely read assembly. You will have access to decompilers, whether it's through Ghidra, IDA, Binary Ninja, other tools. Decompilers are now a relatively robust technology, and consequently, reverse engineers should always make use of them. But if you want to really reinforce the assembly language, then you should go through the assembly, read that, just go ahead and hide your decompile window, and then you'll get a good opportunity to fully reinforce your knowledge of the assembly and make sure that you really understand it, because only if you really understand it will you be able to figure out what sort of inputs the phases of the binary bomb are expecting.